everyone. In this video, we are going to discuss about the pipelining in the computer organization and architecture. So pipelining is a very advanced concept and it is used to increase the throughput of the system. So let's understand this topic. This topic is very important for the NIC students and it is going to come in the main scientist paper as well as in the scientific officer paper. So let's understand the introduction to pipelining. So pipelining is a mechanism which is used to improve the performance of the system in which multiple tasks are executed in an overlapping manner. So pipelining is actually the one which is related to the overlapping thing. And here in the system, we are going to have multiple tasks and all of these are going to get working in the overlapping manner. It is a decomposition technique that means the problem is divided into sub-problems and these sub-problems are assigned to the pipes and then they are going to operate. Pipelining is a hardware mechanism. Just remember that this is a hardware mechanism. This is very important point. It accepts the new input in at one end and the input which is going to be present at one end and the output which is going to be present at the other end will be actually in the same pipeline. So it will be not that the input is going to get converted to the output and then when it is going out of the pipe, then only the new input can come in. The new input at one end will come before the previously accepted input is going to present itself as an output at the other end. Now, this new input is executed along with the old input. That means it is an overlapping thing and it allows the overlapping execution. Here the pipeline is divided into 4 stages basically, like fetch, decode, execute and write back. So every instruction basically is decoded into 4 parts and these 4 parts are fetch, decode, execute and write back. In the similar manner in the pipeline also we have 4 stages, that is fetch, decode, execute and write back. Now let's understand what exactly we do without pipelining and then we will understand what is done with pipelining. So let's assume we are having 4 instructions as I1, I2, I3 and I4. These are the 4 instructions that we are having and we are going to execute them in the non-pipelining manner. In the non-pipelining manner, we are going to execute them. So these are the 4 cycles that are the fetch, decode, execute and the write back. So every instruction will have these 4 cycles in order to get its completion. I1 will start from the fetch, then it will go to the decode, then it will go to the execute and then it will go to the, here it will not be present here, it will be present here to the write back. So one after another the thing will happen. So for the very first particular instruction it is going to execute alone. Now once the I2 is going to get executed and will get out of the system, at the same time the new one will get in. Okay, then I2 will execute until and unless I2 gets the completion, I3 will not start. Once I2 is completed, then our instruction will start executing with the I3. Okay, so I3 will start executing and then so on, I4 will start. You can see we have encountered 16 cycles here overall when it comes to the execution of the 4 instructions. So with the 4 instruction, 4 into 4 is going to 16. So 16s are the number of cycles that are going to get involved here. Now, without pipelining, there are some points that you need to remember. In non-pipelining, new input are inserted after the completion of the old input. So there is no overlapping. It means it is a non-overlapping execution. Here each pipe is called stage or segment. Between the stage interfaces, registers are used to store the intermediate result. So every stage in between, we are going to have some interfaces and these interfaces are going to store the intermediate result, which is going to get provided to the next stage. Now, interface registers are also called as pipeline register, buffer or latch. So this is also called as buffer or latch or the pipelining register. So this was about the non-pipelining thing, or you can say without pipelining. Now, let's understand the difference with the pipelining. So suppose we implemented the pipelining concept. So if we are going to take the same 4 instructions, I1, I2, I3 and I4, and here we are going to execute in an overlapping manner. It means the simultaneous execution. Now, this is the very first thing, I1 will execute, then I2 will start executing with I1. Now, here you can see I1, I2, I3 are executing. Here I1, I2, I3 and I4 are executing. So in the same manner, the things are going to be like when I1 starts with the fetch cycle, and completes the fetch cycle, I2 can immediately start with the fetch cycle. So here you can see I1 completed the fetch cycle and moved to the decode cycle. So the I2 started with the fetch cycle. When I1 is completing the decode cycle and is done and moved to the execute cycle, at the same time I2 moved from the fetch to the decode part. Then I1 moved from the execute to the write back, and I2 moved from the this particular thing called as execute. So you can see I1 is executing in different cycles, and I2 will not wait for I1 to complete the write back and then to start with the fetch cycle. It will start with the immediate cycle which is available there. So now you can see we are going to have only the 7 cycles here in the entire scenario. So 7 cycle, as I4 is going to get execution here. So we are going to have 7 cycle. In non-overlapping, we were having 16 cycles. So you can see with only n equal to 4, that is the number of instructions, there is a difference of at least a half, more than half is the gap in between these things. So execution is very good as when we are doing things with the pipelining, and execution is going to take a long amount of time when we are going to do the things with the non-pipelining. So that's why pipelining is very efficient technique. Now, there is one concept, that is the with pipelining interfaces. So we need to understand what we exactly mean by interface. So there are stages, as we all know, that we are having 4 stages: S1, S2, S3, and S4. These are similar thing that you read at fetch, decode, execute, and the last one is the write back. Okay, now these all are actually connected to the clock. Okay, these all are synchronized because we want the things to be in a synchronized manner. That's why they are all connected to a clock. In between all these stages, we are going to have the interfaces. So this particular thing is called as interface between the 2 stages. So this is called as the interface, register, or buffer, or latch. Whatever concept you are studying, in whichever book, you might encounter these 4 different words used for the interfaces. So between every stages, we are going to have the interfaces, and this is our clock, which will be helping us to synchronize. So in order to maintain a sync in between these all things, the clock is used, and to provide the results, we are going to have interfaces. So when S1 is completing and it's going to S2, instruction is going to S2, this particular interface will store the intermediate result, which is going to get transmitted to the next stage, intermediate result. This will be our case with the pipelining interfaces. So this was all about the pipelining and the introduction to pipelining. In the next upcoming video, we are going to discuss about the performance evaluation, and there you will know the difference between the performance gain of the pipelining and the non-pipelining environment. So that was all for this video. Thank you.